welcome to Codage VIT, and this is today's POD, minimum bin distance number. Let me directly explain you the question. Okay, see, the thing is they'll be providing you with around n numbers. Okay, first of all, they'll be asking you in first line to enter number of integers, and on the basis of n values, you have to enter n numbers in n lines. Okay, for example, suppose if I'm telling a value of n is equals to 3, so for the next 3 lines I have to give 3 numbers as an input. Okay, suppose the numbers are 4, 2 and 5, so these are my 3 numbers, and after giving these 3 numbers I have to give one more number m. Suppose value of m is 6. Now see, what I have to do is I have to convert 4, 2 and 5 into their binary format, as well as I have to even convert m into its binary format. After converting all these things, after doing all these things, I have to figure out what is the minimum distance between binary conversion of 6 and the other 3 numbers given. See, like suppose, see if this is 4, this is 4 and this is 6. Okay, they are binary converted form. Now see, 0 and 0, they both are same. 1 and 0, they both are not same, and 1 and 1 are same. So I can say that the minimum bin distance between 4 and 6 is 1. Okay. Similarly, suppose for 2027 and 119, these are the binary conversions. If we'll be checking for each and every index whether the values are same or not. If they are same, if they're not same, then we have to increase the value of count by 1. And after doing all these things, you'll find that the minimum the binary distance between them is 7. Okay, so based on that, we have to find those numbers which are having minimum binary distance from the given set of numbers. Okay, that I hope, see, even you can read the question and you can understand what it is. I don't want to waste my time explaining the question, so let's move on to the code. As the question says, in first line I have to take input. Okay, so this basically tells me how many numbers I have to take. Okay, now see, now what I'll be doing is I'll be creating a list. I'll name it as L1. L1 is equals to int input for I in range. Now see what is happening over here. Basically, as the question says, for next n line I have to take numbers as input. That is what I'm doing. Int input for I in range n, if value of n is 3. So for 3 times it will be asking the user to enter a number, and the number will automatically get stored in the list named as L1 list. Now this is now when this is done, I have to even take m as input. Okay, so here I have basically taken the value of m. Now I have to convert these numbers into their binary format, because that is the next most important thing which I have to do. So see, for binary conversion in Python, we have got some inbuilt functions in it. So let me create a variable first. M binary is equals to dot replace 0b with what? With, so see what I'm doing over here. If I would have just written bin m, so in my m binary variable I would have got a binary number. But if suppose the value of m is, suppose if the value of m is 6, so I would have got 0b110. That is a problem with it. So in order to replace 0b, I have written over here dot replace 0b with nothing. Okay, it's the most, this whole syntax is most important for converting a given number into a binary number directly using Python. Okay, it's very much important. So this is what I've done. After doing this, I have to even convert these numbers. I have to even convert the numbers stored in the list into binary format. So for that, what I'll be doing is I'll be creating a dictionary. Later you'll come to know why I have created a dictionary. Now see, for I in L1, I is equals to, same way I'll be converting them into the binary format, dot replace. Now see what is happening. Suppose if my list, let me take some example. Suppose my list is having numbers as 4, 2, 5. Okay, this is my list. So here basically I'm creating a dictionary, okay, whose key will be these numbers 4, 2 and 5, and values will be their binary converted form. Okay, let me show you what will be my dictionary. My dictionary will be looking like this: 4 colon 100, I guess. 2 colon, let me see what's the binary conversion for 2. Suppose for binary conversion of 2 is something like 010. 5 colon, for 5 let it be what, for 5 let it be 010. Okay, just for the example. So this is what I'll be having in my dictionary. Okay, this is what I'll be having in my dictionary, and these will not be numbers, these will be strings. Okay, so this is how my dictionary is gonna look. This is my list. Here I've taken the list of numbers and using these numbers as key, their binary converted values are stored as a form of values. Okay, so this is how my dictionary looks. Now once I'm done with this, now see, the most important part. The thing is, sometimes what happens is, see, sometimes what happens, as you can see over here, this is the binary conversion value and this is the binary converted value. As you can see, both of them are not having the same lengths. Okay, both of them are not having the same length, they are having different lengths. So in order to make them of same length, I have to even write a program. I have to even do some coding in it. Okay, in order to make them of same length. Now see, let me create another list, L2. Now this L2 will be having, L2 will be having, wait a minute, let me write first, then I'll explain. It will be for I in L1. So what is happening over here? Basically, I've created a new list, L2 list, which will be having binary converted values of all those decimal numbers present in the list L1. Now, why I'm doing this? You then also use of creating this dictionary and then creating this list two separately. I'll tell you why. What I'm doing. See, max len is equals to max L2 comma len of now see what I'm doing. In this L2 list, I'm having all the binary converted values. Okay, binary converted values. So among these values, I'm trying to find out which one among them is the maximum one. Once I'm getting the maximum one, what I'm doing is I'm calculating the length of that maximum binary converted value and length of the m binary values. And on the basis of these two values, I'm finding which of the following values having maximum values. Okay, maximum length. That is what I'm doing. Once I get the maximum length, now what I'll be doing is, see, suppose as you can see, this is having maximum length as compared to this. So what I'll be doing is length of this minus length of this into 0, and those zeros will be added in front of it, so that I could make these two binary converted values of same length, and then I can do my check operations. So for that I have to write, see, if len of m binary is less than max len, add what I have to add. Let me show you what I have to add. Max m binary is equals to 0 star add plus m binary. Doing, see, this is exactly what I'm doing. Okay, I'm finding out which among them is having lower value, lower length, and based on that I'm adding zeros in front of them. Okay, because it would make no difference if I add 0 in it. Now this is done. For now I have to do the same process for those numbers, for these numbers also which are present in the dictionaries. Okay, in this dictionary, for them also I have to do the same thing. Let me show you how I'll be doing this. For I in dic, if max len is greater than, that is the case, then control C, control V in place of this, add is equals to same thing, 0 star add plus. Okay, so now I'm done with entire code. I just need to make one more check operation, which will be checking what is the value, what is the minimum binary distance. Okay, so till now let me explain you what I've done. I've taken the inputs. Okay, I've taken the required inputs in the required format. Now once this is done, I'm converting them into their binary formats. Okay, and for the given list of numbers, I'm storing them into a dictionary as key value pairs. And once this is done, okay, once this is done, I'm finding out, this entire code is basically to find out which number is having maximum length, and on the basis of that, I'm converting all the other numbers of the same, I'm making all other numbers to be of the same length by adding 0 in front of them. Now once this is done, see what I have to do. Now this time, now I have to make a function again. Let me write the function. Def. Okay, let me name it as def, and it will be taking two parameters. it will be taking two parameters. Let me set count equals to 0 for I in then of m binary. If see if m binary I is not equals to string I plus equals to return count. Now see what actually I'm doing is, as I said in the question, we have to check each and every indexes. For this index, I have to check the same index over here. They both are same. Okay, similarly, see over here, index 0 and index 0, both of them are equal to 1. Index 1 and index 1 over here, it's not. They both are not equal. Okay, and index 2 and index 2 over here, they both are same. So this is what I'm doing. I have to take each and every index and I have to check them whether they both are same or not. Okay, whether the values over there are same or not. If they are not same, then I have to increase the value, count value by 1, and at the end I'll be returning the count value. Now see, for I in DIC, for I in DIC, k is equal to, basically I'm passing on each and every number into the in the function m binary comma this I is equals to DIC I comma k L3 and L3 dot append. Okay, now see what is happening. I've created a list, an empty list, and what is this list gonna do? See, this empty list is going to store the count values. What I'm doing is, for I index DIC, DIC, if k is equals to, I'm passing on these values into the functions, and it will be returning me a count value. That count value is stored inside this k. Okay, is stored inside this k, and my dictionary, okay, which used to have, see, this is the value for the dictionary, right? This is the value for the dictionary. Now it is changed into a tuple which will be having this DICI and k, both these values stored in it. And basically these k values are even stored in this empty list which I've created, L3 list. Why I'm doing this? In order to find the minimum list. Okay, in order to find a minimum value. So see, minimum difference, I need the minimum difference, so which is nothing but minimum of L3. Now once I have the minimum value for I in DIC, if DICI DICI1 is equals to mindiff, then in that case print I. That's all. This is the entire code. Okay, I passed on each and every binary values into the functions, on sending them to the functions I got the count value. Count value over here is nothing but the minimum, is the binary distance. Once I got my binary distance, what I've done is I've converted my dictionary's values into a tuple which will be having its binary converted values as well as the count value in it. And the count is even stored in another list, L3 list. It's stored in L3 list because I wanted to have the minimum binary distance. Once I got my minimum binary distance, I'm checking for how many values in the dictionaries the minimum difference is same, and based on that I'm printing it. Okay, let me just run this, then you'll understand whether it's gonna work or not. See, suppose if I want to enter three values, 4, 2 and 5, and value of my m is 6, then in that case I'm getting 4 and 2 as my answer, as you can see over here also. Suppose, see, value of m is 6 and 4, 2 and 5 are entered, then based on that my output should be 4 and 2, and that is exactly what I was getting. See, this is what exactly I'm getting. So this is the entire code. It's a lengthy code. It's not a lengthy code, but yeah, you need to understand. I mean, I've just done the basic things which I have to do. Normal conversions, then passing on to the parameters, getting the count values. It's easy. It's easy to understand. And yeah, you have to just try to listen it again if you don't understand. That's all. Thanks for watching.